Hello guys, welcome back to our channel. In this video, we will be seeing a systematic way of naming inorganic compounds. Before starting with the video, let us have a look at the periodic table. Here, periodic table is divided into three main groups, that is metals, non-metals and semi-metals. The most stable element are group 18 elements, also known as inert group of atoms. Reason being that they have complete octet. Every other elements in the periodic group strives to be like group 18 by attaining outer shell configuration like it. This part of the table is called S block and contains group 1 and group 2. As we can see, group 1 elements have electronic configuration of ns1 and to attain inert gas configuration it has to lose one electron, and thus the elements will readily lose one electron and attain an oxidation state of +1. Similarly, group 2 elements have general electronic configuration of ns2 and thus it will readily lose 2 electrons and will show +2 oxidation state. This explains why S group elements generally forms cations. Similarly, we can explain why group 13A shows +3 oxidation state. Group 14 shows +4 oxidation state. Now in group 15, it can either gain or lose electrons, and this is the reason it shows variable oxidation states like +3, +5 and -3. Same is the case with group 16. These also show variable oxidation state of +4, +2, +6 and -2 also. In case of group 17 elements, they only need to gain one more electron to complete their octet. So these show oxidation state of -1 and generally forms anion by gaining one additional electron. By this discussion, we brushed our concepts of oxidation state, cation, anion and oxidation states shown by different groups. These concepts will help us in naming inorganic compounds, which we will see now. We will be dividing the inorganic compounds into three major groups and we will see their nomenclature individually. First is ionic compounds, second is molecular compounds and the third is inorganic acids. Let us look at the first case, that is ionic compounds. Metals and non-metals generally react to form ionic compounds. Now, there are metals that show only one oxidation state and there are some metals that show multiple oxidation states as discussed earlier. In both the cases, nomenclature will be done differently. Let us have a look at the case 1 where metals involving one oxidation states are involved. We will take an example of NaCl. In such compounds, we first name the metal followed by the stem name of non-metal with an IDE ending. So, the name here will be sodium followed by stem name of chlorine, that is CHLOR, and end it with ide, which comes out to be sodium chloride. So, the general form comes out to be name of cation or metal plus stem name of anion or non-metal plus the suffix ide. Let us see some more examples. Let us take an example of CaCl2. Name of the metal, that is calcium, plus stem name of non-metal, that is chlor, and suffix ide, that comes out to be calcium chloride. In BaS, that is the name of metal is barium, stem name of sulfur and suffix ide, that comes out to be barium sulfide. Let us move on to another class of ionic compounds in which metals showing multiple oxidation states are involved. We will take an example of HgBr and HgBr2. Mercury shows multiple oxidation states. For example, in HgBr, oxidation state of mercury is +1 and in HgBr2 the oxidation state of mercury is +2. In such compounds, we name the metal first followed by its oxidation number, which is written in Roman numerals, which is followed by stem name of non-metal ending with the suffix "ide." So the name of HgBr will be mercury, followed by oxidation state 1, followed by stem name of bromine, which comes out to be mercury 1 bromide. Similarly, the name of HgBr2 will be mercury 2 bromide. And as you can see here, the oxidation state is written in Roman numerals. So the general form comes out to be the name of cation or metal plus the oxidation state in Roman numerals plus stem name of anion or non-metal plus the suffix "ide." Let us see some more examples. Let us take an example of COCl2. We will name it as the name of metal, that is cobalt, plus oxidation state of cobalt, that is 2, plus stem name of non-metal, that is chlor, and suffix "ide", that comes out to be cobalt 2 chloride. In CuCl2, name of metal is copper, plus oxidation state of copper is 2, plus stem name of chlorine and suffix "ide", that comes out to be copper 2 chloride. Let us move on to the next class of inorganic compounds, that is molecular compounds that occur between two nonmetals. In such compounds, we use prefixes that indicates the number of atoms of each element present in the compound, which is shown in this table. If we have 2 atoms, then we will use the prefix di. If 3, we will use the prefix tri, and so on. Let us look at the way of nomenclature by taking an example of N2O5. Here we have 2 nitrogen atoms, so we will add the prefix di followed by the name of element, that is nitrogen. Next we have 5 oxygen atoms, so we will use the prefix pent, and second element name will end with suffix "ide. So the name comes out to be dinitrogen pentoxide. Now you may ask, why didn't we write oxygen first and then nitrogen? That is because in these compounds the element with lowest electronegativity is named first. So here the electronegativity of nitrogen is less than that of oxygen. So we started the name with nitrogen. So the general form comes out to be prefix plus name of less electronegative element plus prefix plus name of more electronegative element plus the suffix "ide". Let us see some more examples. We will take an example of PCl5. Name of less electronegative element, that is phosphorus. We have 5 chlorine atoms, so the prefix will be penta and then chloride, that comes out to be phosphorus pentachloride. Next is CO2. Name of next less electronegative element, that is carbon. We have 2 oxygen atoms, so we will use the prefix di followed by oxide. So the name comes out to be carbon dioxide. Let us move on to the next class of inorganic compounds, that is inorganic acids. These acids are further divided into 2 parts. First is non-oxy acids and the second case is of oxy acids. Let us have a look at the case 1 of non-oxy acids with an example of HCl. As you can see, HCl devoids of oxygen, so we named this class of acid as non-oxy acids. These are named by using the prefix hydro followed by the stem name of non-metal with suffix IC followed by the word acid. So the final name will be hydrochloric acid. So the general form comes out to be hydro plus stem name of non-metal plus the suffix IC plus the word acid. Let us see some more examples. Here we have HBr. We will start with the suffix hydro followed by the stem name of bromine plus the suffix IC followed by the word acid. That gives us a name of hydrobromic acid. The next example is HI. The name of this acid is hydroiodic acid. Let us move on to other class of inorganic acids, that is oxyacids. These acids consist of three elements, that is hydrogen, a non-metal, and oxygen. These acids are named by using the stem name of non-metal element followed by the suffix OUS if the element is in its lower oxidation state, followed by the word acid. If the element is in higher oxidation state, we add the suffix IC after the stem name of non-metal followed by the word acid. Let us understand this by taking an example of HNO2 and HNO3. In HNO2, the oxidation number of nitrogen is +3, while in HNO3, the oxidation number of nitrogen is +5. So, in HNO2, we will use the suffix OUS, and in HNO3, we will use the suffix IC. This gives us the name of HNO2 as nitrous acid and the name of HNO3 as nitric acid. So the general form comes out to be stem name of non-metal plus the suffix OUS plus the word acid if the element is in lower oxidation state. The other case is if the element is in higher oxidation state, it will be the stem name of non-metal plus the suffix IC plus the word acid. Let us see some more examples. Here the oxidation state of sulfur is +4 in H2SO3 and +6 in H2SO4. So the name of H2SO3 will be sulfurous acid and that of H2SO4 will be sulfuric acid. In the next slide, I have inserted a block diagram of all the topics that we discussed earlier. This brings us to the end of the video. I hope this video helps you in naming inorganic compounds. For more such videos, make sure to subscribe our channel and thank you for watching.